So, all right, this is me. I work for Microsoft now. Before I was at Amazon. And the thing to take away from this slide, other than I have two beautiful daughters there, is that I've worked primarily in software services and large data problems and cloud-based computing. Oh, and since this is Test Bash, you might have read my three-part series in the Testing Planet on the future of testing. So this is a really good book, How to Measure Anything. And if you haven't read it, I highly advise you download it to your Kindle or whatever and give it a look. But in this book, Mr. Hubbard, the author, makes the point of defining measurement. And you think, measurement, I know what that is. But if you really think about it, it's kind of hard to define. And he defines it as a quantitatively expressed reduction of uncertainty based on one or more observations. And that's a pretty good definition. Now, is there anything that you, a room full of testers, are interested in reducing the uncertainty about in your daily job? Shout it out. What would that be? About the X of my product. The what? Quality? Quality, yes. OK. So testing, I think, can be described. And yes, I am, on my very first slide, defining what testing is. A pretty bold move, right? A quantitatively expressed reduction of uncertainty about the quality of a system under test using one or more observations. Now, if you may not believe that yet, hopefully by the end of my talk you will believe that, but that's going to be the basis, the foundation of what I'm going to say going forward. So if you accept that, then just to give you a little more basis, so that first definition of measurement, that's data-driven decision making. We want to use data in our decision making. That's a very scientific thing to do. And if you use that data to assess the quality of your product, that's data-driven validation. Now, within a subset of that data-driven validation, you could do that in production. Remember, do it in production. That's the name of the talk. You could do that in production, and we call that testing in production. And that's going to be the topic of my talk today. So why do we test in production? I mean, what is testing in production? Testing in production is making use of real users. Why are we making use of real users? Because real users are weird. They do things that we can't anticipate and we can't always expect. So I'm a tester by my profession, and I'm very proud of when I find that weird edge case, right? And I say, oh, I broke the product, I broke the product. But is that really what a real user would do? And even if it was what a real user would do, did I find everything that the weird users would do? No. So by putting in production, we get exposed to those real users. And it's also about making use of the real production environment. And why you want to make use of your real production environment? Because some guy might be screaming into your hard drives, right? You don't know what's going to happen in production. So by testing in production, you get exposed to that. So this is a tweet I got a few days ago, and it's from a fellow named Ben. And I actually don't follow Ben. I got it because it was retweeted by someone you might know in the audience here, one of our coordinators here, Rosie. She retweeted it. And you can read what the tweet says. It says, I'm beginning to feel that a slow, nasty XP machine running IE is an essential part of anyone's testing environment. Now, as a Microsoft guy, that immediately made me perk up and look at that. And I thought, yeah, it's probably true. And the IE in question is probably IE6. And I'll tell you, even Microsoft is running away from IE6. I have a whole website dedicated to say, please do not use IE6. Stop using it. It's no good. So I thought about that, and I said, yeah, that's probably true. You've got to test for those kinds of users. But then you've got to test for users running Windows 7 and users running Windows 8 and Vista and Mac OS. And they're using IE, and they're using Firefox, and they're using Opera. And this matrix gets pretty big pretty quickly, right? This is a huge matrix of operating systems, browsers, bandwidths, user types, et cetera, that you have to run in the lab. And that becomes unwieldy. You can't test all that, right? So what can you do instead? Well, this is an example of something that Hotmail, now Outlook.com, did. What they did is they measured actual performance of user workflows in production amongst their millions of users. So they had millions of users, and they measured, in this case, how long does it take to load the inbox? That's PLT, stands for page load time. How long does it take to load the inbox for millions of users? And remember, this is including going across the public internet, going through the Microsoft routers, the Microsoft load balancers, going through various switches, going to various services, talking to various partners. This is the real deal that you're going to find in production. In this case, you can slice and dice it however you want. This graph slices it by browser and shows the load time by certain browsers, but you can actually slice and dice it by operating system, by location around the world, by which data center they're hitting, by anything you want, really. And they're using JavaScript to make these measurements, and they're doing it for users around the world, and they budgeted for 500 million measurements per month in order to get this data. And this data has been useful. They've identified bottlenecks and re-engineered to get rid of the bottlenecks based on this real-world performance monitoring data. Now that 5 million measurements a month, that's pretty big data. So let's talk about what big data is. I think many of you in the audience have probably heard the phrase big data. So I'm just going to give you a definition for what big data is. Big data is often defined by 3 V's. The first of those V's is volume. So volume, we've got megabytes going to gigabytes to terabytes. Terabytes, is that big data? Well, I can go to Amazon.com and buy a 3 terabyte drive for like 120 bucks. So I don't think that's that big. It's big, but it's not that big. Let's talk about petabytes to exabytes to zettabytes. OK, so maybe zettabytes is going too far right now. Can anybody guess what the size of the entire internet is today? This is including video. This is including audio. This is including text, including pictures. What is the size of the entire internet, the entire World Wide Web, I should say. Entire internet is meaningless. The entire World Wide Web in zettabytes. Anybody want to guess? You think it's 100 zettabytes, 1,000 zettabytes? Yeah, it's about a zettabyte. 1 zettabyte for the entire web. So zettabytes are really big data. We're not quite there. But in the terabytes, petabytes, maybe even exabytes range, that's where we're at. So it's also about velocity. What do I mean by velocity? Well, that little magnifying glass means that if we're instrumenting our services and our products are constantly emitting a stream of data, this fire hose of data coming at us, that's velocity. The little merge sign on there is about how fast we can react to that data. Why is the merge sign there? Because it's about a thought exercise that I've modified a bit, but was posed by IBM about a year ago. And the thought exercise is this. If you're merging onto a busy highway in your car, and you can't see the highway. All you have is a picture of the highway from 1 minute ago. Could you safely merge onto that highway? No, you'd die. So this is about some data needs to be reacted to immediately, and some data doesn't. And the third V is variety. On the left, there's a relational database, highly structured, highly normalized. On the right, a Twitter bird, from a Twitter stream. Twitter data would be what we call unstructured data. Yeah, it's limited to 140 characters or whatever. It has hashtags and @ signs, so it has a little bit of structure, but not much. Log files are unstructured data. Is XML unstructured? Well, it's got metadata in it. Basically, the rule of thumb about structured versus unstructured, if it lacks the structure you need to do the processing you want, it's considered unstructured. So there's your 3 V's, and hopefully that's going to bring you some value. In this case, let's talk about the value of doing quality assessment, of reducing the uncertainty about quality of your product. So I don't expect you to take in this whole slide. This is meant to be sort of a whoosh kind of thing. And what this is an internal Microsoft product, but external products exist that do the same thing, that takes the Twitter stream and dices and slices it up and does analysis and turns the Twitter stream into actionable data. In this case, actionable data about Xbox Connect. So you could see that, positive to negative sentiment is 2 to 1. You could see, in early March, something was happening here. And it turns out that we were having our R&D showcase. So that was a lot of talk about various Connect things going on in R&D. But could you use this for quality to find bugs? Yeah, you could actually. If you released a new version of the product and you saw then these numbers go crazy, any of these numbers up here can be graphed over time. If you released a new version of the product and you saw sentiment, negative sentiment shoot up, or you saw the phrase buggy or piece of garbage shoot up, then you know that you probably have a bug and you need to delve deeper. So this is a high-level example of how that Twitter stream can be acted on. So I said this talk is about testing in production. So what does this have to do with testing in production? Well, it's an equation. If you're going to use data to do your quality assessment, and let me be clear, I forgot to say this earlier, when you're using data-driven engineering or data-driven quality assessment, it still includes your classic test cases that you're running today. That's data. I got test results. That's data. I'm talking about adding to that data, especially adding data from production. So if you're going to use data, and some of the best and biggest data is in production, then you're going to test in production. So the question is then, why do I want to test in production? I already made that case about weird users and screaming into hard drives, but let me make another case for why we test in production. So I'm here, I don't know if it's showing that well, but this is a walking path from one point to another on some island. I don't know where it is. Maybe you guys know. A walking path that goes over water. Okay, I don't know if you can see that here. And of course, it's a bug, so I'm going to show it in Google, not Bing. So how would you find this? I say how will you find it with a unit test. How would you find that before you go to production? Are you going to test every combination of points in the world, A to B, and their walking directions? It's absurd. You're not going to test it. The point is, with the right telemetry in production, it's trivial for Google to sense when this happens in production if we as testers have put the instrumentation in place that says, if any route goes over water, make sure there's a ferry or bridge there, right? So if the telemetry is there, if the instrumentation is there, this is trivial to find in production. Yes, a couple of our users will be affected, but we find it, we fix it quickly, and we fix it quickly. And to say whether we could find this in production, well, I say Google is self-aware to know that this route may be missing sidewalks. They do say that. So, thank you. OK, so let's go to another example. Let's talk about Facebook, how they do testing, right? Everybody here is familiar with Facebook, I'm sure. So Facebook has a couple of tools, and this actually is a couple of years, they did this a couple of years ago. They're using some different tools now, but the point is the same. So they use an open source program called Ganglia. It's a monitoring tool to collect all kinds of stats across thousands of servers in their data centers. And Ganglia is sort of the raw data, and that's open source. And then they make use of another open source product called Hadoop. Hadoop is a product for handling and processing large data sets. And actually, I'm going to go into more details later and explain Hadoop to you. For now, it's just sort of, it's there and they're using it. And they use Hadoop to create what they call an operational data store. The operational data store collects all the data from Ganglia and other sources and persists it in a non-lossy way so that they can get trending analysis and look at the history of all kinds of stats. They could look at system information like CPU, cache hit rates. They could look at application data such as API latencies and API hit rates. And they could look at business metrics, such as revenue and click-through rates. They could look at all these metrics and plot them over time. And they claim 5 million metrics. Now, it's kind of a meaningless statement. What do they mean by 5 million metrics? I actually asked the person that actually said that what they meant, and they weren't totally clear about it either. They're a little dodgy about that. But it means that they have thousands of servers, each emitting thousands of pieces of data every day. And that's big data. So now, how is Facebook like Gondor? And if you saw my tweet, I promised I would show Boromir. How is Facebook like Gondor? Well, does everybody remember in Lord of the Rings when Boromir is told that Aragorn is his king, he says, Gondor has no king. Gondor needs no king. Exactly. So there was a Facebook Quora answer and blog post a while ago that said, Facebook has no testers. Facebook needs no testers. How does Facebook get by without testers? Let's see. According to them, they have a few different things they do. Number one is engineers stay with the code every step of the way. What does that mean? That means from the time they write it and check it until the time it's deployed. When it's deployed, the engineer that checked in the code has to be on an IRC chat channel while it's being deployed and watching what's happening. So that's one thing they do. They do dog fooding. I don't know if you know what dog fooding is, but that means that Facebook internal users get everything first. So if there's any bugs, the internal users are going to find it. And then they're using the metrics, those metrics I showed you in the last slide. They're using metrics to find system problems and system-related issues, problems at scale. They're using metrics to see when user engagement drops off or when a significant number of users are affected. And notice they said significant number of users. They don't care if 1 or 2 users are affected in their multi-million user database, user base. They don't care. But if a significant number of users are affected, they'll find the bug. So this is how they get by without testers. Now, you're thinking to yourself, is he actually promoting this? Is he actually saying this is a good process? Or is he mocking it? You don't know yet, right? Both is the answer. So the same Quora answer goes on to say Facebook can do this because Facebook doesn't need particularly high-quality software. So it's a business decision on their part. So you all know what Facebook, everybody here knows what Facebook's quality is. It's not perfect, but it's good enough. So they've made the business decision to do without testers and do this very data-centric type testing. But however, if your software requires to be more high quality than Facebook, you might want to take a different approach. So in other words, what Facebook does is literally just throw it in production, right, without testing. And that's not what testing in production generally is. In this case, it is. This is sort of the exception to the rule. In general, though, is testing in production about just throw it in production? And I'm going to say, I'll tell you right up front because I don't want there to be any mistakes about it. Generally, it's not. It's part of a measured approach throughout your testing cycle. So here we have a software development life cycle, very simplified, that I hope looks familiar to you, that blue represents developers, purple represents testers. Okay? Probably should have put a legend on there or something. So your developers hopefully are writing unit tests, running them, checking them in, hopefully. And then you as a tester, you then get a hold of the product and you do the functional testing, and then you get multiple components together, you do the integration testing, and then you sign off on it. Just a yes or no. Does this look familiar to folks? Yeah? OK. So If I tell you, then you're going to, after it releases, do testing in production, write your telemetry, use the data, et cetera, et cetera. Look what I just gave you. I just gave you more work to do. Congratulations. Are you happy with my talk? You know, I don't think you're going to be happy with my. You don't. It's not like you have all this copious spare time that I'm going to now go into production, do testing in production also, right? So I'm going to propose a model that is just a proposal. You're going to have to modify it to meet your own culture and your own needs. And the model looks like this. Developers still do unit testing. But now I'm going to give the developers the functional testing. Why is that? I'm going to say anything component level that a developer can test, the developer should test. Okay? Now, notice that that box has reduced. We might do less functional testing. Integration testing still belongs to the tester, but again, we might do less of that because then we're going to continue testing once we're in production. So that's the model I'm showing. And instrument everything, so the developer's responsibility is to add the instrumentation here so you can do the testing in production here. And then your responsibility is to specify the metrics and optics to use. Just one proposal. So hopefully that slide does point out that testing in production is generally not just throw it in production. The answer is just throw it in production? No, unless you're Facebook. So I'd like to talk to you, categorize the kind of, I've shown you some examples of testing in production already. I've shown you what Hotmail did. I showed you what Facebook did. I showed you that Twitter stream. But I want to give you more of a categorization about what testing in production is. Those three examples I gave you, they're called passive validation. When I say passive, people think it must be a negative thing. It's not. It's not a negative term at all. Passive validation is very powerful. But why is it called passive validation? Because there's data out there. Either we instrumented for it or it's ambient data. There's data out there and we're using it. We're consuming that data and making quality decisions based on that data. So it's passive. We're not actually executing anything other than analysis of the data. We're not executing anything against the system under test. So active validation is when we execute things against the system under test. And when do we execute things against the system under test? We do that when we run test cases before we release, right? So active validation is using something called synthetic transactions. And synthetic transactions look a lot like test cases. Test cases are a subset of synthetic transactions. Synthetic transactions are, I make up some data, I make up some workflow or scenario, and I execute it against the product, and I assess the results. Okay? So that's what I mean by active validation. So since I've given you passive examples, let me give you some active validation examples. So again, this is another one that you're not meant to read, you're sort of just meant to take it in. This is Office Service Pulse. It's an internal dashboard used by the Microsoft Office team. And every graph and every little metric on there is generated by using active validation or active monitoring. And obviously, it's not meant to be used in this form. It's meant to be zoomed in on, and then you can look at your metrics of interest. So I'll give you a more specific example. Exchange, Microsoft Exchange was an on-premise product that we moved to the cloud, and actually we maintained both an on-premise and a cloud version. But when we created the cloud version, the team said, how are we going to test the cloud version of Exchange? We have thousands of test cases we run in the lab against the on-prem product. Can we use those to test in the cloud version of Exchange? And indeed they did. So what they did was, Azure is Microsoft's cloud platform. It's sort of like Amazon Web Services. It's a competitor to that. So what they did is they designed a test framework to run from Azure and execute not all 7,000 or how many test cases they have from the lab, but certain key test scenarios running from the cloud against the service in production. So what does this give them? Well, it gives them test results like pass and fail, but that's not as useful to them. What's really useful is when you run those synthetic test cases or those synthetic transactions over and over again against production, you get some interesting results. Number one is, if you time how long any of those transactions takes from beginning to end, you have an interesting piece of data. If you run it over and over again and graph that over time, you have some really interesting data. Because if you then deploy the next version of your product and you see the performance for some key scenarios has now fell through the floor, it's gone bad, you know something about that key scenario. You know there's a bug in the performance. Similarly, availability is about, imagine you have a test case and it's a little wonky. It transiently fails once in a while for no good reason as far as you can tell. Maybe there's a race condition going on in the product or something. And if that test case, you run it once and you get a failure result, it doesn't tell you anything, right? Did it find a real bug or did it just transiently fail? Take that same test case and run it repeatedly, in this case in production, and it turns out that it fails 0.001% of the time. That means you have 99.999% availability for that particular scenario. So by running these synthetic transactions in production, you get performance and availability trending in history. Now, fault injection, active validation uses synthetic transactions, and synthetic transactions don't always look like test cases. In this case, the synthetic transactions in question are what we call fault injection. So what we're talking about here is if your product is designed to be fault tolerant. If your product's not designed to be fault tolerant, don't do this. If your product is designed to be fault tolerant and you want to test that, you test it in the lab first. Take my word on that. Test it in the lab first. But then how do you know it really works in production? You test it in production. So Netflix is, I believe, available in the UK. It's an online streaming service. And what they do is famously they have what's called a chaos monkey. A chaos monkey is supposed to be like a monkey gone wild in your data center, taking out servers and services left and right. So the chaos monkey script actually injects faults. It actually takes out servers and services in Netflix's deployment to assess that indeed Netflix keeps running. Netflix is fault tolerant. They wouldn't do this if Netflix wasn't designed to be fault tolerant. And they attribute Chaos Monkey to the fact that in April of 2011, when Amazon Web Services went down, they're hosted in Amazon Web Services. When Amazon Web Services went down in April 2011, Netflix stayed up. Okay? And Chaos Monkey was so good that they added other monkeys and gorillas, et cetera. They call it the Simian Army. That's their name for it. So Chaos Gorilla, what does Chaos Gorilla do? Chaos Gorilla takes down an entire data center, simulates taking down an entire data center. Well, in June 2012, an Amazon data center went down. Netflix went down too. So it didn't work perfectly. They actually did respond and said, hey, Chaos Gorilla should have helped us with this. It didn't help as much as we thought, so now we got to go back and re-engineer Chaos Gorilla. So they're going to learn from that mistake and iterate. Now, speaking of Amazon going down, Amazon actually has a planned outage every few months called Game Day. In Amazon Game Day, they simulate the outage of an entire data center. I don't think they actually power it down. I mean, all you got to do is turn off the network going to the data center, and it's basically, for all intents and purposes, down. So they actually simulate the outage of an entire data center. And they let the service owners know in advance it's going to happen. But then on the day of the event, they send out some bogus email saying hey, the data center's burned down, and it's offline. And your service is expected to run. And at Amazon, they do, because they're designed to do so. So that's another form of active validation. Now, that sounds pretty risky, right? So synthetics have risks. If you're going to do that kind of fault injection, that obviously has some real risks to it, you can imagine. I don't even have to explain what those are. Let me tell you about some more subtle risks of using synthetic transactions. So one of the subtle risks of synthetic transactions has to do with the testing of the Harvard Business Review publishing website. Harvard Business Review publishes business articles and business books. And they tested the website using testing in production, using synthetic transactions. They would actually run a search case on the word monkey. And that search case would return one result. It would return who's got the monkey. Okay? It's a time management book, actually. It was actually a time management book at the time called Who's Got the Monkey, and that's the one result you'd get. And one day, the test fails. It returned two results. It returned who's got the monkey and who's got the monkey now. So, okay, I'm running my test case in production. It's a dynamic database I'm running against. This is not unexpected, so not a big deal. I'm just going to change the test case. But someone actually luckily looked into it further, and they talked to the marketing team. And the marketing team said, yeah, Who's Got the Monkey? A really popular book. People were always searching for it all the time. So we asked the author to write a sequel. Yeah, so that's one of the risks of using synthetics, active validation in production. You can, quote unquote, change the shape of your data, whether it's changing the shape of your engineering data or your business data. You've got to be careful. You've got to do things like data tagging and data cleanup, data filtering, et cetera. Here's another risk of using your synthetics. This is actually an actual forum post from an Xbox user saying, hey, I got this thing that says, dear test first name, dear test last name. Congratulations on your purchase of the store test bundle input. And he says, WTF, I did not buy any test store bundle inputs today. So I know the team that ran this test. And a couple of these slipped through where they were actually doing these synthetic transactions and accidentally used not real user accounts, but they used fake user IDs that they created that actually corresponded to real user IDs in production, and some users got these emails. And they were able to quickly fix this in an actually very clever way. I'd be happy to talk to you over a beer. I don't have time to talk about it now. So you don't want to expose your test data to users like Amazon does. If you go to Amazon and you search for test ASIN, Amazon Standard Identification Number, you'll get things like this, the electronics test ASIN 207. You know, yours for the low, low price, that's the price is off the end of the screen. But Amazon does this all the time, and they still do it today. So you could actually do that yourself and take a look at some of their test data. And it's not a good thing. It creates a perception of low quality. It doesn't meet the user's needs. So I think you've learned a lot already about active versus passive. So let's show you what you've learned already. So active versus passive. So passive is about using the real data, real users, the real telemetry coming off your system. Active is about you run synthetic test cases, synthetic transactions against the system under test. Which one gives you insight into real usage, active or passive? Yeah, passive, because that's the real data. However, if you want something reproducible and well understood, right? So user scenarios can be varied all over the place. You want something that's going to do the same thing over and over again, it's going to be your active. If you want to cover a vast variety of environments, remember that Hotmail example? They can get all the browsers, all the operating systems, all the bandwidths, all the locations around the world. That's going to be passive. But however, and also personally identifiable information. That's important, right? If you're actually pulling data off your production system, there are rules around what you're allowed to do with personally identifiable information. Names, credit card numbers, IP addresses, all have to be either avoided altogether or handled very carefully. That's going to be your passive. And may adversely affect or alter production data. Well, I just showed you that. That's going to be your active. So I talked about passive, I talked about active. I want to talk about another passive methodology that's actually so important, I just wanted to call it out here. It's called experimentation. Experimentation is simply trying things in production, getting the data, and then acting on it. So you might try something in production, find out it really works, and then double down on it. You might try something in production and find that it doesn't work, it's buggy, et cetera, and you remove it. And being able to remove those bad things quickly is very powerful. So to have a great idea, have a lot of them, essentially. Thomas Edison said that's what experimentation is about. So there's a thing called A/B testing, which I'm not going to go into vast detail on, but in A/B testing, you put several different experiences or several versions of your code out there and send different users, unbeknownst to them, to each of those experiences, and then compare between those user sets to see which ones are best or which ones are higher quality. Dog food and beta, like I said before, dog food is your internal users use the product before anybody else. Beta is a select user base of external users get to use it. And these all make use of something called exposure control. So I said put things in production, and you're all thinking, oh my, I can't do that. That sounds scary. Exposure control is a way to mitigate your risk. Exposure control says you only put it out to a limited number of users. So dog food and beta are very limited. Your A/B testing, you could just put it out so that just 1% of the users see your new product, et cetera. Now Google makes a lot of use of experimentation. Eric Schmidt, the former CEO there, talks about how they have these 1% launches. They launch out to 1% of users, and they can slice and dice however they want. Slice and dice what? The data, of course. And shadow launching is another form of experimentation where you're not launching it out to any users. But wait, you just said experimentation is putting it in front of users. With shadow launches, what you're doing is you're launching a new version of the product that receives the same production data as the existing version in production, so you fork the data coming in, but it never actually is exposed to the end user. So what I mean by that is, for instance, when Google launched Google Talk, they wanted to test the system for your status lights. You see the little status lights there? The status lights are actually very chatty. It's the number of users logged in at any time, times their friend list, times the number of status changes. So they wanted to get it right. So they launched it so that they had people logging in and out of Gmail and their various products. They launched it so that it would track people's statuses, but it wouldn't show the statuses anywhere on the screen. The only people that saw the status changes were the engineers assessing the quality of the product. That's a shadow launch. Now, stepping away from Google for a second, I want to talk about at Microsoft, experimentation has been very powerful. We found that amongst all the decisions that people had at Microsoft about things to change in the product, and most of these are design decisions. So I'm going to talk to you a lot more about also code quality, which we're interested in. But a lot of these were design decisions. And these are design decisions made by people that should know better, designers, directors, VPs. Amongst all those decisions that we tested using experimentation, 1/3 turned out to be good. 1/3 turned out to make no difference, and 1/3 were actually bad. So that means only 1/3 of the time, amongst our best minds, do we make the right decision. With experimentation, we're able to find those 2/3 very quickly and weed them out and only keep the 1/3. So, OK, let's talk about code quality. Let's talk about experimentation for code quality. So Netflix, going back to Netflix, they're deployed to AWS in the cloud, so that's why there's a big cloud up there. and they receive 1 billion API requests per day. And those 1 billion API requests are obviously big data, right? So what they do is they have their current system launched in the cloud. That's what the blue servers are. The blue servers are some version of one of their services running in the cloud. And the little smiley faces means that those virtual servers are carrying traffic. Now I want to launch the next version of that service, right? But I want to assess the quality before I launch it out. So what I'll do is I'll spin up some servers, deploy the vNext to those servers. That's so blue is vCurrent, red is vNext. And what will I do? I'll put one of those servers into production. That's called the canary deployment. Canary in a coal mine, right? It's a form of experimentation. I can now compare how this new server does compared to the old ones. I could look for errors. I could look for usability. I could look for errors in the system, memory leaks, et cetera. And only when I'm convinced that that guy is good, then I'll put all these guys into production. And I'll still keep those guys around, because at 1 billion API hits per day, I'm going to leave those guys run at scale overnight and make sure they're all running well before I decommission these guys. And there you have it. I've now launched the next version of my product. When I put that canary into service, if I found a bug, I would have pulled it out, fixed the bug, and then repeated the whole process. So I talked about data-driven decision making. So it makes sense to talk to you a little bit about a brief look at data science. And I'm not going to teach you about means and averages and standard deviations and linear regression, because I assume either you know that or you can look that up on Wikipedia or whatever. Those are all basics. I want to give you some of the interesting gotchas and tidbits that you wouldn't necessarily find in the statistics handbooks. And so I'm going to talk about all three of these things. So let's see how this works. So this is the first computer I ever laid hands on. Yeah. Yes, I'm old. Thank you for laughing. So I want 5 volunteers. Let's see, I know you've been a quiet audience, but there's 5 people. I've been working in software for 19 years. I want 5 people to just tell me how many years you've been working in software. Just shout out the values. 38. How many? 7. 11. 1. Okay, so was the highest one I heard 38? Okay, so I don't know how powerful this is going to be. So the lowest one I heard is 1. The highest is 38. That means the median years in software, I only had 5 samples, but I could say there's a 93.75% chance that the median is between 1 and 38. I know, that's a pretty big range. But, but the point is you could actually use fairly small data sets, very small. So I talked about big data, big data, big data, and you're thinking I don't have big data. You could actually use fairly small sample sizes, in this case 5 samples, to give you powerful information about a group, about a much larger group. Now, notice I said that's the median years in software for the test bash attendee. I didn't say it's the median for testers. That's something that you have to understand your sample bias. I asked 5 people at this conference, so I don't know that the 5 people in this conference are reflective of the entire industry. So then I have to be aware that I could state things about my sample that, oh, it's testers at the Test Bash conference. I could even be more restrictive and say that's the median for testers at the Test Bash conference who are extroverted enough to shout out their years in software. So that's when you're taking samples. Be aware of things like sample bias. Who are you sampling, and are they representative of the audience and of the system in general? The other thing I want to teach you is that averages are your enemy. So taking the mean of something is something we're all kind of trained to do. But a mean or an average is actually a very lossy data point. You lose a lot of data when you take the average of something. And so here's a distribution of how long it takes to execute some workflow. Let's say it's to log into a website. All right? So how long it takes to log into a website down here. And then this is actually something called a probability density function that you don't need to know what that is. Just assume this is a histogram, okay? This many people took this many seconds, this many people took this many seconds, right? So you might be tempted to take the average and say, oh, that's the average performance for our website. But in reality, when you analyze the data, it turns out there's actually 2 different sample populations in here, 2 different distributions. So who might these 2 different distributions be? They might be testers and real users. They might be users of our V1 product and users of our V2 product. So averages are lossy, and you have to understand your underlying population of data that you're using. Now, I promised to teach you a bit about Hadoop. And that's why I keep looking at my watch. I don't want to run out of time before I teach you about Hadoop, because that's a really important bit here. Because Hadoop is a very powerful open source product for processing large data sets. And what do I mean by processing large data sets? Imagine anything you can do with a SQL database. You can do a select and sort and count. That's processing data. So we're not using SQL here, but that just gives you an idea of what you can do when you're processing data. So Hadoop lets you process terabytes or even petabytes of data. Okay? And how does it do it? Well, let's assume here's a little data set of 9 characters. Let's assume that's 90 trillion characters instead. Okay? I didn't want to write 90 trillion characters. I couldn't fit them on the slide. But there's 9 characters there. Let's assume it's 90 trillion characters, right? And we want to find out the letter occurrence of each character, how many A's, how many B's, how many C's, et cetera, in that set. How do we do that if we had 90 trillion characters? It won't fit on a hard drive. It won't fit in a database. How are we going to do that? Well, we use Hadoop. So Hadoop has 2 pieces. The first piece is a Hadoop distributed file system. So you need to store this data somewhere. And I think it's fairly instinctual to most people in this audience that you can use distributed storage. You could break it up into pieces that actually do fit on hard drives, that do fit on servers. As long as you know how to put it back together, no problem. So that's the first step we do, is we break it into pieces. And what do we do then? We replicate it. Why do we replicate it? Because someone might scream into your hard drive, and there you go. You lose one of your servers, you still have 2 more, and you're still good. You haven't lost any data, because losing a piece of data can be very bad. So we distribute it, we replicate it. Now we actually do the processing. This is the second part of Hadoop. The second part is something called MapReduce, and I'm not going to teach an extended thing about MapReduce. That's a lecture into itself, but I'll give you the high level about MapReduce. Remember, we want to count the characters, right? So the fact that we've broken it up into small pieces actually makes that pretty easy. What we got to do is take the processing to the data. We're used to taking the data to the processing. I want to process a bunch of data. I put it in a database, and the database then processes it. Now we're going to take the processing to the data. The data is already distributed. Now we're going to fire up processes on each of those distributed machines that's going to analyze the data on those machines. And what's going to find? Oh, 1A, 2Ds, et cetera. Okay? So that makes sense. That's called the map part. We've mapped the processing to the data and done the processing. Then we have to reduce it to a final result. And you can imagine if we had trillions of characters in the input, the output is not going to be nearly as big. The output's going to be A through Z and the associated number of characters in each one of those. So that's Hadoop in a nutshell. Cosmos is an internal Microsoft product that does much of the same thing. And the only reason I'm showing it to you is because I actually have some numbers I could share about Cosmos. Specifically, it runs on tens of thousands of computers across 3 different data centers, stores hundreds of petabytes of data, and processes over 2 petabytes of data a day. What it was a process? It processes every click on Bing, and every result to that click is recorded and processed so that we can improve the quality of Bing. But that's not all. That's just one data set. You can imagine other data sets we have too. So, and that's just a picture of a Microsoft data center that shows that we have these like containers that are shipped in on truck and just set down in the data center, and they're filled with servers. You plug them in, and you're good to go. Oops. Did I skip something? No, I didn't. So, how do we use these big data tools? So these are Spartans from the Xbox game Halo. And that guy is a headless Spartan. A headless Spartan is not supposed to exist. But it turns out that they do exist. And they're invulnerable. You can't kill them. So people were creating headless Spartans that you can't kill. Great fun, right? If you're 14, I guess. So what did the Halo team do to find this problem? Well, they used something called HD Insight. HD Insight is Hadoop running on Azure. Now you have Hadoop as a service. That's hugely powerful. Instead of having to get your own servers, you just use Hadoop as a service. Now, Halo is having hundreds of thousands of requests per second. That's a pretty high request rate. That's a lot of data. They have so much data that they can't even, for a while, they couldn't even analyze it all. And they say that we can't anticipate the 101 things that will go wrong. The only thing we control is ensuring our team responds appropriately to those situations. So we're getting all this data. We couldn't anticipate a headless Spartan. But it turns out the headless Spartan was a hack that you can create using a modified Xbox. Okay? And using this data, we're able to identify the headless Spartans, who was creating the headless Spartans, fix the bug, and disqualify the people that created the headless Spartans from playing Halo. Pretty powerful stuff. How does it work? Just in the highest level, simple thing, the Xbox console is emitting data all the time. It goes to our servers. HD Insight processes it. We bring it down to the Power Pivot to create visualizations in SharePoint, and we can take action on them. So They also found less obvious bugs. Using that data, there's a wealth of insight to be found. They could find all kinds of subtle bugs. And to illustrate that, I'm going to actually give you a very non-technical example of how data can find fairly subtle things. And this is about a store in the US called Target. And Target is sort of like a Marks and Spencer. Okay? It's a department store. They sell clothing and food and all kinds of stuff, right? And the story goes that an irate man goes into a Target store, goes to the manager, he complains, he says, he throws down a coupon book, and he says, this coupon book is filled with baby strollers and formula and diapers and such, and you sent it to my 14-year-old daughter. How dare you send her this coupon book? What are you trying to do? Tell her, you trying to encourage her to get pregnant? And the manager's very apologetic. He says, I'm sorry, sir. And the guy goes away. And 2 weeks later, the manager is so upset by this, he calls the guy back to apologize again. He says, sir, I'm really sorry about what happened to you. I just want to call in to make sure that everything's okay. And the guy responds to the manager. He says, well, I owe you an apology. Turns out you knew something that I did not know. You knew my daughter was pregnant. And it's not because she bought a pregnancy test. It's because she bought cocoa butter and magnesium supplements and a blue rug and a big bag. That's all you got to buy, and the Target data scientist can say you're pregnant. And the chief data scientist says, even if you're following the law, you could do things where people get queasy. So that's your little moral moment. With great data comes great responsibility, I guess. And my final example of using big data, this is, again, from the Exchange Online team. And the blue line, which might be hard to see, is availability for a given service. The green bars are where they predicted they would have availability problems. In other words, the green bars existed before the other graph existed. Notice not all of them are predicted, but most of them are. 75% of the time, they can predict dips in availability within a 24-hour period. How can they do that? Well, they get lots of data about availability. They put it into Cosmos. They apply a machine learning algorithm to it. Machine learning, if you think about linear regression, it's linear regression on steroids. You come up with a model, a mathematical model. It describes your data. And if it describes your data well enough, you can predict into the future. That's what machine learning is. And they can predict outages before they happen using passive telemetry. So in summary, I defined what testing is. Testing is measurement used to reduce the uncertainty about quality of your product. I said the best way to do that is in production. You don't have to do it just in production, but the best way to do it is in production. I talked about active versus passive methodologies. I told you to read this book. And do I have time for questions? I think I have about a minute or so, so I have zero time. I do not have time for questions. If you want to ask me any questions, I'd be happy to talk to you over beers or coffee later. Thank you.
Thank you, sir.